On behalf of KPR80, I welcome Dr. Velkennedy sir from Aggregate College of Engineering, Madurai, to give his wonderful speech on the topic highway pavement design. I welcome you, sir. Please carry over the session.
Good morning to all. I am Dr. R. Velkennedy, Professor, Aggregate College of Engineering, Madurai. Our topic is highway pavement design. Highway pavement is designed to support the wheel loads imposed on it from traffic moving over it and temperature stresses. Basically, we can classify the pavement as flexible pavement, that is bituminous road, rigid pavement, that is cement concrete road, whereas semi-rigid or composite pavement and interlocking cement concrete pavements. The factors to be considered for the design of flexible pavement as wheel load of heavy vehicles or traffic loads. For example, Chennai Metropolitan alone having 40 lakhs of vehicles on road and new registration has around 3,000 vehicles per day. The next factor which affect the design of flexible pavement is subgrade soil. The bottommost layer of the pavement as subgrade. The strength of subgrade is expressed as CBR in percentage. If the CBR of the subgrade is less, the pavement layer thickness is more. Then climate factors such as temperature stresses. Then pavement component materials in different layers such as soil, stone aggregate, and bitumen as a binding material for flexible pavement, whereas cement as a binding material for rigid pavement. Then drainage and environmental factors such as rain and traffic as mixed traffic or individual traffic. Then we can discuss the components of highway structures. The terrain are up and down, forming roads by cutting and filling. Cutting and filling are done to get desired gradient. Normally, ruling gradient or design gradient is to be provided throughout the length and breadth of the road. Ruling gradient is obtained when the cutting and filling become balanced. When filling or embankment over the subgrade and pavement layers are flexible or rigid structures. The pavement layer such as subbase, base course and surface course, whereas cutting, prepared cutting, subgrade and pavement layers of flexible or rigid pavement. Highway materials. Next, the material which are used for highway as soil, stone aggregate, then bituminous a binder for flexible pavement, bituminous mix, and Portland cement as a binding material for rigid pavement, such as cement concrete road. Then desirable properties of soil subgrade. We already discussed the subgrade is the bottommost layer of the flexible pavement. The properties of subgrade as it should be stability, it should not be incompressibility, then permanency of strength, and it should be minimum change in volume and stability under adverse condition of weather and groundwater. Then it should have good drainage property and easy to compact. Then we can discuss desirable properties of stone aggregate such as hardness, toughness, strength, durability, shape, and porosity. The aggregate which are used for road work should be hard enough to resist wear and tear. Then evaluation of various properties of stone aggregate. Hardness. The hardness can be determined by conducting Los Angeles abrasion test according to IS 2386 part 4. The permissible value of hardness is less than 40%. Next, toughness. The toughness can be determined by conducting aggregate impact test as per IS 2386 part 4, The permissible value of the toughness should be less than 30%. Then strength. The strength is required if the vehicle is parking continuously on the road. The strength of the aggregate is reduced. The strength can be determined by conducting crushing test as per IS 2386 part 4. The permissible value of the strength should be less than 30%. Then durability. Durability can be determined by conducting soundness test. The loss of aggregate due to weathering action can be determined by conducting soundness test. Nowadays, even rainwater itself contaminated. During the rain, there may be a possible of reaction between rainwater and bituminous mix. Result is stripping of aggregate. The test can be according to IS 2386 part 5. Then loss of aggregate after 5 cycle with sodium sulfate should be less than 15%. Loss of aggregate due to weathering action in magnesium sulfate should be less than 18% after 5 cycle. Then another property is safe. The aggregate which are used for road work should be in angular shape. Then only there may be a bonding between aggregate to aggregate. So the aggregate which are collected from river bed should not have an angular shape, that is called bubbles. Then there may not be any bonding between aggregate to aggregate. Then the aggregate which are used for road work should not be too flaky, can be determined by conducting flakiness index, and should not be too elongated, can be determined by conducting elongation index. The combination of flakiness index and the elongation index is called combined index that can be determined as per IS 2386 part 1. The combined index should be less than 30%. Flakiness index should be less than 15%, and the elongation index should be less than 15%. The combined together is called a combined index, should be less than 30%. Then the porosity, the presence of voids over the aggregate can be determined by conducting water absorption test using IS 2386 part 3. Water absorption value should be less than 2% according to MACADAM specification. What is MACADAM? Any idea about MACADAM? MACADAM means Ministry of Road Transport and Highway. Next, pavement section by various layer. That the bottommost layer is called subgrade. The pavement consists of one or more layer. The topmost layer is the surfacing, the purpose of which is to provide a smooth, abrasion resistant, dust proof and strong layer. The base, which comes immediately next below, is the medium through which the stress imposed are distributed evenly. Further distribution of load are also provided by the subbase layer. And subgrade is the compacted natural earth immediately below the pavement layer. The top of the subgrade is also known as formation level. Normally, the subbase in India is granular subbase or well-graded gravel, whereas base course is waterborne macadam or wet mix macadam, and surface course has bituminous surfacing, maybe bituminous concrete or dense bituminous concrete or bituminous macadam or dense bituminous macadam. Then granular subbase, one day out 10 in our Indian condition is 288 cubic meter. Out of the 288 cubic meter in grade 1, 53 to 9.5 mm size, 50%, 144 cubic meter, 9.5 to 2.36 mm size, 20%, 57.6 cubic meter, and 2.36 mm and below size 30%, and water required for preparing 288 cubic meter of granular subbase 27 kiloliter. The granular everywhere in India, the subbase is granular subbase. Next, where the grading for close grade granular subbase material, the aggregate which are collected for preparing granular subbases, passing 75 mm 100%, passing 53 mm size 80 to 100%, passing 26.5 mm size sieve 55 to 90, passing 9.5 mm size 35 to 60%, and so on. Then the granular subbase which are used for subbase should have CBR value is 30%. You know what is CBR? CBR is California bearing ratio. CBR is California bearing ratio. Then 1 day outturn for subbase as a wet mix macadam, 225 cubic meter is required. Out of the 225 cubic meter, 45 to 24.5 mm size 30%, 26.4 to 2.36 mm size stone metal 40%, and 2.36 mm and below size 30%. Then water required is 18 kiloliter for preparing 225 cubic meter of wet mix macadam for 1 day outturn. Next, specification of material which are used for prepare base course. The Los Angeles aberration value of aggregate which are used for base course as a wet mix macadam is 40% maximum. Aggregate impact value 30% maximum. Combined index, I mean flakiness index and elongation index should be less than 30% maximum. And water absorption value for finding the property of porosity should have 2% maximum. These are the specification of stone aggregate which are used for wet mix macadam. Then the material which are used for wet mix macadam, the grading is 53 mm passing 100%, 45 mm passing 95 to 100%, 26.5 mm passing nil, 22.40 mm passing 60 to 80%, and so on. The wet mix macadam which are used for base course should have CBR value 30%. What is any idea about CBR? California bearing ratio expressed in percentage. Next, pavement. So the flexible pavement, that is bituminous pavement. We are using bitumen as a binding material. Any idea about bitumen? Bitumen is destructive distillation of petroleum product, whereas road tar is destructive distillation of coal and wood in a earth. The bitumen can be graded as paving and industrial grade. Then the bitumen can be classified based on sources as A type and S type, where A type means sources from Assam petroleum product, whereas S type means sources other than Assam petroleum product. Based on the penetration test, we can classify bitumen as 80/100, 60/70, and 30/40 grade. Nowadays, we are classifying the bitumen based on viscosity, that is visco grade 10, visco grade 10T, visco grade 30, VC30. Then road tar. Road tar is destructive distillation of coal and wood in a earth. So the road tar can be classified as RT1, RT2, RT3, RT4, and RT5. Like that, we are having asphalt bitumen. The bitumen contains some mineral is called asphalt. The asphalt bitumen can be classified as natural asphalt and rock asphalt. Like that, the bitumen is available in the wet condition, that is called emulsion. In emulsion, 40 to 60% as bitumen, remaining is water. The emulsion bitumen can be classified as rapid setting RS, medium setting MS, and slow setting SS. Then cutback bitumen can be classified as rapid curing medium curing, and slow curing. In flexible pavement, bitumen is a binding material, whereas in rigid pavement, cement is a binding material. Then various method available for flexible pavement design is design formula developed by US Corps of Engineers and California bearing ratio method. Then last method is group index method. Then the design parameters which are considered for design of flexible pavement is intensity of traffic. That intensity of traffic normally 700 commercial vehicle per day per lane. That can be conducted by traffic volume studies. That can be collected by conducting traffic volume studies. Normally, the growth rate R is 8% per annum. That is normally we already discussed in a Chennai alone, every day new registration is 3,000 vehicle per day. So that's why the growth rate is 8% per annum. Then the design life of flexible pavement is 15 years, whereas the design life of rigid pavement is 20 years. The design wheel load is normally for considered as 5,100 kg, whereas if it is 5,100 kg is heavy traffic, if it is medium traffic, wheel load is only 4,100 kg, whereas light traffic, the wheel load is only 3,000 and 3,175 kg. Then another tire pressure. Tire pressure is normally expressed by kg per centimeter square or PSI, pounds per square inch. The tire pressure is normally 7.2 kg per centimeter square. Then the CBR of the subgrade soil 8%. Normally, the bottommost layer is called subgrade. The strength of the subgrade is expressed as California bearing ratio in percentage. Next, the estimating the designed traffic. So normally the conducted traffic volume is laborious process. We may not conduct the traffic volume every year. Like population collected once in 10 years, like that we are collecting traffic volume is also once in 5 years or once in 10 years. So this is the formula which are used for finding the anticipated traffic volume. For example, the traffic volume is 700 commercial vehicle per day at the last count by the year of 2012. If you want to predict the future traffic volume by the year of 2019, we can use this formula. This formula called A is equal to P1 plus R power n plus 15, where A means number of commercial vehicle per day for design. When you call commercial vehicle, any idea? If the vehicle load is more than 3 ton is called a commercial vehicle. Then P, 700 commercial vehicle per day at the last count by the year of 2012. Then R, annual rate of increasing of commercial vehicle normally take us 7 to 9%. In our case, we are taking 8%. Then when n number of years between the last count and the year of completion of construction in 2019, that is 2012 to 2019 is 7 years. Then the formula A is equal to 701 plus 0.08 power 7 plus 15. We may get it 3,805 vehicle per day by the year of 2019. So based on the number of vehicle per day, we can classify the traffic A to F. If the traffic is A means number of commercial vehicle per day is 0 to 15, whereas B is 15 to 45, whereas C is 45 to 150, whereas D is 150 to 450 number of commercial vehicle per day, whereas like that, whereas F means 1,500 to 4,500, and another grade is called G. G means expressway and number of commercial vehicle more than 4,500 is coming under the category of G grade. Next, there are the three methods we were discussed. One is called design formula developed by US Corps of Engineer. Another is called group index method. And the most popular method which are adopted in India is called CBR method. Now we can discuss the method is developed by US Corps Engineer. This is the formula for finding the overall thickness of the pavement, where T is equal to root P, then 1.7 by CBR minus 1 by P pi power 1 by 2, where T is pavement thickness expressed in centimeter, and capital P is P load we are considered as 5,100 kg, that is heavy traffic, and another called CBR of the subgrade soil taken as 4%, and small p is the tire pressure, where is 7.2 kg per centimeter square. Then by using this formula, we are getting 44.78 centimeter, consider as approximately, we can take it as 45 centimeter. That total thickness of the pavement is 45 centimeter. That 45 centimeter is including thickness of subbase as a DSP, granular subbase, and thickness of base course as waterborne macadam or wet mix macadam, and surface course as a bituminous concrete or bituminous macadam. Then we can discuss CBR method. In the CBR method, we are estimating cumulative standard axial load, that is repeated load. Cumulative standard axial load CSA can be determined by using this formula, where N is initial traffic on completion of construction, that is number of commercial vehicle per day, considering the number of lane also. Then small r, annual growth rate of commercial vehicle, normally 7 to 9%. Then N is design life of pavement, taken as 15 years for flexible pavement, 20 years for rigid pavement. Then F represents vehicle damage factor, equivalent to number of standard axial per commercial vehicle on the road stretch. Values are assumed as 3.5 on rolling and plain terrain. So the terrain can be classified as plain terrain, rolling terrain, mountainous terrain, and steep terrain based on the slope of the terrain. If the slope of the terrain is 0 to 10% is plain terrain, 10% to 25% as a rolling terrain, and 25 to 60% as a mountainous terrain, and greater than 65% of the slope of the country is called steep terrain. Then values are assumed as 3.5 on rolling and plain terrains and 1.5 on hilly terrain when commercial vehicle are 150 to 1,500 per day. And we have to assume 4.5 on rolling and plain terrain and 2.5 on hilly terrain when number of commercial vehicle are greater than 1,500 per day. Then D is the land distribution factor. Then IRC has recommended IRC 37 in the year of 1984 has given the table for finding the distribution factor. This is the table given by IRC 37 1984. The transverse distribution of heavy vehicles across the width of the carriageway T can be taken as 1 undivided road with the single lane carriageway is 1. Then whereas distribution factor T as 0.075 undivided road with the 2-lane carriageway. Then D as 0.4 for undivided road with a 4-lane carriageway. Like that, we are finding the land distribution factor T using the table given by IRC 37. Then this is the problem for finding the cumulative standard axial. So this is the problem for finding standard cumulative axial. Normally the standard covers that cumulative standard axial is expressed in million standard axial. So this is the problem. The initial traffic after the completion of the construction of a two-lane undivided highway is estimated to be 3,500 commercial vehicles per day. Design the flexible pavement for a life of 15 years, that is N is 15 years, using the data given below. Then design CBR value, that is CBR is 8%. Growth rate R is 6.5% per annum, and average vehicle damage factor value of CV is equal to 4. Assume the land distribution factor for undivided road with two-lane carriageway as per IRC recommendation is 0.75. This is the formula. Using this formula, we may get it. The cumulative standard axial is 150.63 million standard axial, approximately 153. Then using this value, we have to find the thickness of various layer of the flexible pavement, such as subbase, base course, and thickness of surface course, using the chart given by the IRC. So in the chart, they are having the 10 curves. The CBR, there is a curve for CBR 2%, CBR 3%, and CBR 4%. Yeah, for our problem, the CBR is CBR is 8%. So you have to choose the curve having CBR 8%. Then we are having cumulative standard axial is 150. So you have to use, this is the chart for cumulative standard axial of 1 to 10 million standard axial. Then another graph is the CBR chart for cumulative standard axial of 10 to 150. So our standard cumulative axial is 150. So the x-axis represent cumulative standard axial value of design traffic 10 to 150, whereas y-axis represents the total thickness of the pavement in mm. So our graph is CBR 8%, corresponding to CBR 8%, the cumulative standard axial is 150. So you may get the approximately thickness of the pavement is 640 or 620. Total thickness of the pavement is 640. Then we have to find the thickness of various layers such as subbase, base course, and binder course can be determined by using the another table recommended by IRC. This is the table is recommended for cumulative standard axial 1 to 10 million standard axial. Another table which shows the cumulative standard axial 10 to 150. For 150, whereas the CBR is 8. CBR is 8. Cumulative standard axial 150. So for the last row, cumulative standard axial is the CBR 8, then cumulative standard axial is 150. The total thickness of the pavement is 660. Out of the 660, 200 mm is a subbase. Normally in India, the subbase is semi-granular subbase, and 250 mm is base course. In India, everywhere the base course is granular base or waterborne macadam or wet mix macadam, whereas the binder course is dense bituminous macadam. Dense bituminous macadam 160 mm and the surface course is 50 mm as a cement concrete surfacing as a 50 mm. This is the procedure for finding the various thickness of the highway pavement by using CBR method. Then the pavement section by CBR method, pavement section. So the bottommost layer is called subgrade. The CBR of the subgrade is 8%. If the CBR of the subgrade is 30%, then the total thickness of the pavement can be reduced to 400 or 350. If the CBR of the subgrade is 2%, then the total thickness of the pavement is increased to 800 mm. Whereas in our case, the CBR of the subgrade is 8%. That's why total thickness of the pavement is 660 mm. So the out of the 660 mm, 200 mm as a subbase, granular subbase, and 250 mm as a base course, granular base course, or we can go for waterborne macadam or wet mix macadam. And binder course is 160 mm dense bituminous macadam, and the surface course is 50 mm bituminous concrete, 50 mm bituminous concrete. Next, we have to discuss another method is called group index method. Normally, the group index method, we are considering the quality of subgrade. So normally, the subgrade is soil. The strength of the soil can be determined by conducting liquid limit, plastic limit, and percentage of fines passing 0.75 mm sieve. So, if the soil which are available in the subgrade is good, means the liquid limit should be less than 35% and the plastic limit should be less than 15% and the plasticity index should be less than 10 or 15%. Any idea about plasticity index? Plasticity index is liquid limit minus plastic limit is called plasticity index. Another parameter which are considered for the strength of subgrade soil is percentage of fines passing 0.75 mm sieve. That is 50%. For our problem, we are consider the soil portions passing 0.75 mm sieve or 75 micron is 50%, liquid limit is 40%, and plastic limit is 20%, and anticipated traffic volume is over 300 commercial vehicle per day. Then, if the group index method, this is the formula for using group index value. Normally, the group index value may be vary from 0 to 20. If the group index is 0, the soil is very good, we can considerably reduce the thickness of the pavement. If the group index is 20, the thickness of the pavement is very high, I mean 800 mm or 900 mm. So the group index is represents the strength of the subgrade soil. If the group index where A is portion of material passing 0.75 mm sieve greater than 35 and not exceeding 75% and expressed as a whole number 0 to 40. Whereas B is portion of material passing 0.75 mm sieve greater than 15 and not exceeding 55% expressed as a whole number 0 to 40. Whereas C is the value of liquid limit in excess of 40 and less than 60% expressed as a whole number 0 to 20. Whereas D as the value of plasticity index. We already discussed the plasticity index is liquid limit minus plastic limit exceeding 10 and not more than 30 expressed as a whole number from 0 to 20. Next, the group index method using the formula that is. So A means we already discussed A is 35 not exceeding 75. In our problem, we are considering the soil portion passing 0.75 mm, sieve is 50%, whereas A is equal to 50% minus 35%, that A is expressed 0 to 40, greater than 35 and not exceeding 75, where so we got 15%. Then B, yes, we already discussed. B means portion of material passing 0.075 mm sieve greater than 15 and not exceeding 55. So our percentage of passing in not 75 mm sieve is 50%. That's why 50 minus 15 is equal to 35%. Whereas C is the value of liquid limit in excess of 40 and less than 60. Whereas in our problem, the liquid limit is 40%. That's why the C is 40 minus 40 becomes 0. Then D is called the value of plasticity index. So plasticity index is liquid limit 40% minus plastic limit 20%. Plasticity index is 20%. That's why the D is equal to 20% minus 10%. We already discussed D can be 10 and not more than 30. That's why we are minus 10. D becomes 10. Then by using this formula, the group index is 6.5, say 7. Group index is 6.5, say 7. This is the one of the method for finding group index using the design formula. Whereas the another method which are used for finding group index value by using the chart. So this is the chart. This is the chart available. The one of the chart is percentage passing number 200 sieve. That is percentage passing not 75 mm sieve. Whereas y-axis is the group index value. Another chart, x-axis shows percentage passing 200 mm sieve or more. Then y-axis C is group index value. In X, in first graph, liquid limit versus percentage of material passing 75 micron or 200, number 200 mm sieve. Liquid limit, there are the 5 graphs. First one shows liquid limit 60 or more. Second graph shows liquid limit 55. The third graph shows liquid limit 50. Fourth graph shows liquid limit 40. And last graph shows liquid limit 40 or less. So our percentage of passing not 75 mm sieve or number 200 mm sieve is in our problem is 50%. So we have to take that 50% in the graph, that is 50%. And the liquid limit is, in our problem, the liquid limit is 40%. So we have to choose the liquid limit 40% graph and percentage passing on 200 mm sieve or 75 micron is 50, corresponding to 50, liquid limit 40. Here we may get the group index value is 3. In first graph, group index value is 3. In the second graph, another the second graph shows percentage of passing number 200 mm sieve or 75 micron and plasticity index. The first graph shows plasticity index 0 or less. Second 10, 14, 18, 22, 26, 28 and 30. In our problem, the plasticity index is 20. So plasticity index here can be determined. How we can determine plasticity index? Liquid limit minus plastic limit. In our problem, liquid limit is 40%, plastic limit is 20%. So plasticity index is 20%. Plasticity index is liquid limit is 20%, plastic limit, liquid limit is 40%, plastic limit 20%. So plasticity index is 20%. Then in the graph, plastic index 20%, then percentage of passing 75 micron years, 50, so we may get 3.5, 3 and 3.5. That's why the CBR is for first graph, the CB group index is 3. In the second graph, the group index is 3.5 and totally 6.5, say 7. Then using this group index value, we can find the thickness of the pavement. So thickness of the pavement can be determined by using the another chart source, another chart recommended by IRC. Using this chart, we can find the total thickness. So here there are the various curves. The solid line curve shows combined thickness of surface, base, and subbase course, whereas dotted line shows the thickness of surface and base course. The difference between two is called thickness of subbase. So here the graph shows x-axis shows thickness in centimeter, whereas y-axis shows group index of the subgrade. In our problem, we are getting group index is 6.5, say 7. So for y-axis group index is 7 corresponding to x-axis. So the first graph shows base only. So dotted line means thickness of surface and base course. Solid line means thickness of surface, base, and subbase course. So there are the three type of traffic. One is light traffic and medium traffic and heavy traffic. We can classify the traffic light, medium, and heavy based on the presence number of commercial vehicle per day. So here, if the number of commercial vehicle per day is less than 50, shows light traffic. Number of commercial vehicle per day on our proposed road is 50 to 300 means medium, whereas number of commercial vehicle per day in our road is more than 300 per day means heavy traffic. So in our problem, the number of commercial vehicle in our problem is 300. That's why heavy traffic. So we have to choose the graph for heavy traffic. So this is for heavy traffic, medium traffic, light traffic. Then another is called dotted line, is for thickness of surface and base course, heavy traffic, medium traffic, and light traffic. So corresponding to group index 7, then the solid line for heavy traffic, you may get the thickness is around for 45 to 50, approximately 47 centimeter. We can get it from the graph. So this is the heavy traffic for combined thickness of surface, base, and subbase course. This is the combined thickness of surface, base, and subbase course for medium traffic, whereas it's light traffic. So combined thickness is 45 or approximately 47 centimeter for the group index of 7. Whereas thickness of surface and base course for heavy traffic, thickness of surface and base course for heavy traffic is this one. You may get the thickness is approximately 37 centimeter. So the subgrade soil So the subgrade soil may be treated as poor from chart as a group index is 7 and the traffic volume may be taken as heavy. From the design chart, B, the thickness of subbase is 17 centimeter and combined thickness of surface, base and subbase course is 47 centimeter. Hence, the thickness of base and surface course is 47 minus 17 is equal to 30 centimeter. Then payment section by group index method. So the subbase having 170 mm or 17 centimeter thick. Normally in India, subbase is semi-granular subbase or aggregate bitumen, aggregate aggregate with gravel. And in base course is 200 mm. Normally in India, base course is what WPM. I mean waterborne macadam, and WMM, I mean wet mix macadam. And surface course is 100 mm. Normally in India, surface course is bituminous concrete or dense bituminous concrete or bituminous macadam and dense bituminous macadam. This is the procedure for finding the various layer thickness by using group index method. Then it may be seen here that the quality of subbase and base course material is not considered in this method. In this group index method were not considered. Then strength characteristics of the pavement material also influence the thickness of the requirement. Then another thing in this method is the emphasis is given only on subgrade soil type and certain physical properties of the soil. So then this is the chart, another chart recommended by CBR finding the thickness of the thickness of the flexible pavement. So this is the old chart, design chart by CBR method. In the design chart, where x-axis shows the CBR value of the subgrade expressed in percentage, 1%, 0%, 1% to 100%. Whereas y-axis represents the depth of the construction in centimeter. Then there are the 7 curves, A to G. If A curve means number of commercial vehicle per day is 0 to 15, whereas B curve shows number of commercial vehicle 15 to 45, then so on. And G curve, G is number of commercial vehicle more than 4,500 or expressway. So we know how do you classify the rural roads. Rural roads are classified as expressway, national highway, state highway, major district road, other district road, and village road. The road which are connecting village to village are village road. The road which are connecting city to city are national capital to state capital or national capital to abroad or national highways or expressway. This is the table we already discussed. Then rigid pavement. Next we can discuss rigid pavement. We already discussed the pavement. Basically the pavements are classified as flexible pavement and rigid pavement. Nowadays semi-rigid or composite pavement. If you use more than one material called say composite pavement. So the various layers of the rigid pavement is subbase, base course and surface course, and also the bottommost layer of the subgrade, bottommost layer of the pavement is called subgrade. The subgrade is compacted natural earth immediately below the pavement layers. The top of the subgrade is also known as formation level. Over the formation may be subbase, base course, and surface course. Then various design parameters are classification of subgrade based on the CBR value. If the CBR value of the subgrade is less than 2% is called weak subgrade. If it is weak subgrade, minimum 150 mm thick of subbase. Then if the CBR of the subgrade is 2 to 15% called normal subgrade. If it is normal subgrade, 80 mm thick subbase is required. Then, if the CBR of the subgrade is greater than 15%, stable, very stable subgrade, not we may not require subbase. Then the rigid pavement can be discussed due to the stresses called warping stresses. So during the construction, the slab is without warping. Then slab is warping due to variation of temperature. At midday, atmospheric temperature is higher than the slab temperature, so warping down. During the night, atmospheric temperature is lower than the slab temperature, so the concrete slab is warping up. So this is the temperature variations. Then we can discuss the design parameters which are considered for design of rigid pavement as cement concrete road. So traffic intensity, the main parameter which are considered for design of flexible or rigid pavement is traffic volume or traffic density, and another is called CBR of the subgrade soil. In this problem, we are taken the intensity of traffic is 500 commercial vehicle per day per lane, and traffic growth rate are 8% per annum, and design life 20 years. Whereas design life of flexible pavement is 15 years, and design wheel load 5,100 kg. Based on the design wheel load, we can classify the traffic as heavy, medium, and light. Whereas medium traffic wheel load is only 4,100 kg. And another parameter which are considered as tire pressure. Normally, the tire pressure is expressed as kg per centimeter square or PSI. PSI means pounds per square inch. Then temperature variation in cement concrete pavement, the temperature variation is a main parameter we are consideration. The temperature variation is depends upon the area and season. Depends upon the area and season. The temperature can be determined. The temperature of the area can be determined by using this table recommended by IRC. So normally the zone 4, Kerala, South Madras, our area is coming under zone 4. If the slab thickness is 10 centimeter, the temperature variation is 13.2. And if the slab thickness is 15 centimeter for zone 4, Kerala and South Madras, the temperature variation is considered as 15. Whereas 20 centimeters 16.4, 25 centimeters 17.6, and 30 centimeter 18.1. This table is given by IRC. Using this table, we can determine the temperature difference. So temperature variation delta D 17.2 centimeter. This can be determined by using the table and thickness of the slab. We are assumed the thickness of the slab is 20 centimeter. So normally the structural element such as slab, beam, or how we are designing the slab, beam of structural element, we are assuming thickness and we are finding hence safe are not in shear and bending or deflection. Like that, in design of flexible pavement also, we are assuming thickness of slab is 20 centimeter or 25 centimeter, and we have to check whether it is safe due to temperature stresses or due to warping stresses. Then another design parameter which are considered as CBR of the subgrade soil 6%. Using the CBR of the subgrade soil, we are finding modulus of subgrade reaction. This can be determined by using this table. So this is the table given by IRC 58 1988. So CBR is 2%. Then K, modulus of subgrade reaction 2.08 kg per centimeter, 2, not kg per centimeter square. Then if the CBR value is 3, the subgrade reaction is 2.77 kg per the centimeter cube. This is the table. Using this table, we are finding the thickness of modulus of subgrade reaction. And the modulus of elasticity of concrete E is 3 into 10 to the power of 5 kg per centimeter square, and concrete flexural strength is 40 kg per centimeter square, and Poisson ratio is 0.15, and coefficient of thermal expansion alpha is assumed as 10 into 10 to the power of -6 per degree centigrade. Then this is the design step. First, we are assuming the construction joint. So we are providing in cement concrete various joints. One may be longitudinal direction, we are providing longitudinal joints, whereas in transverse direction, we are providing transverse joint such as expansor joint, contraction joint, construction joint, and warping joint. Normally for design, we are taking construction joint spacing, contraction joint spacing. Normally we are assuming the length of contraction joint spacing is 4.5 meter and land width W is 3.5 meter. If it is single land, the width of carriageway is 3.5 meter, whereas if it is two land, the width of carriageway is 7 or 7.5 meter based on the curve. Then if it is intermediate land, the width of the carriageway is 5.5 meter. If it is multi-land, the width of the carriageway is 3.5 meter of each length. Then assume the thickness of the slab H is 23 centimeter. Then this is the formula for finding radius of relative stiffness I, 4th square root of EH cube divided by 12, 1 minus V square into K. Then the value E is for E is 3 into 20 power of 5 kg per centimeter square, and where the H is the thickness of the highway slab is 23 centimeter, and the mu Poisson ratio is 0.15, and K is modulus of subgrade reaction based on the CBR of the subgrade is 4.5. Using this, we are finding I is 91.19 centimeter. Then we are finding L by I, where L is contraction joint spacing 4.5 meter, and I is radius of relative stiffness 91.91 centimeter. L by I, you may get 4.93. Using this value, we are finding the C Bradbury chart C using this table. Whereas if it is Li, L by I is 1, C Bradbury chart value is 0. Like that, if L by I is 12 and above 1. In our problem, we are getting L by I is 4.93. Corresponding 4.93 C Bradbury chart is in between 0.440 to 0.72. So we got C is 0.673. Then the cement concrete slab is distressed due to temperature. The temperature, normally we can consider the loss of cement concrete due to temperature on edge region, corner region, and interior region. Mainly, we are consider edge region and corner region. So, our laid concrete is reduce the strength due to temperature stresses. So, we have to find the residual concrete strength for supporting load FL can be determined by FR minus the loss of concrete strength due to temperature stresses is STE. So the loss of concrete due to temperature stresses STE is equal to E alpha delta T by 2, where E is Young's modulus of the concrete and alpha is temperature variation, where alpha is coefficient of thermal expansion and delta T is temperature variation for finding the loss of concrete strength due to temperature stresses. So this is the formula for finding loss of concrete strength due to temperature stresses. So temperature stresses in edge region we are getting from this formula is 17.28 kg per centimeter square. Then residual concrete strength, our concrete having flexural strength is 40 kg per centimeter square. Flexural strength of the concrete is 40 kg, whereas loss of concrete strength due to temperature stress is 17.28 kg per centimeter square, whereas residual concrete strength for supporting load is 40 minus 17.28, 22.72 kg per centimeter square. Then another is load stress for edge region, another is load stress for corner region. This is the formula for load stress for edge region. This is the formula for load region or interior load region for corner load stress. This is the formula for finding corner load stress. So the corner load stress and edge load stress can be determined by using the formula, or we can use the chart. So this is the chart which are used for finding the edge load stresses. This is the formula for using the edge load stresses. Edge load stresses. This is the formula for edge load stresses. This is the chart. From the chart we can find the edge load stresses. So slab thickness, we are assuming slab thickness as 23 centimeter. In this chart, x-axis shows slab thickness, whereas y-axis shows edge load stresses. Edge load stresses is expressed by kg per centimeter square. Then in the chart there are having 5 curve. One year shows where K is 30 kg per centimeter cube, where K is 15, you can use this curve, whereas K 10, you can use this. So in our problem, the K modulus of subgrade reaction is 6 kg per centimeter cube. So we have to choose this graph. 6 kg per centimeter cube graph can be used for finding edge load stresses. So the thickness of the slab is 23 centimeter. Corresponding 23 centimeter, the K6, you can choose this graph. From this graph, we can find the edge load stresses around 27 kg. So load stresses for edge region 22.5 kg from the chart So available factor of safety on load stress is FL by delta L, that is greater than 1, hence okay. If it is less than 1, what we have to do? We have to increase the slab thickness correspondingly. Now we are assuming slab thickness is 25. Next you have to assume slab thickness is 25 and 27 and etc. So this can be the design is by trial and error method. In the first trial, we are assuming slab thickness is 23 centimeter. In the second trial, we are assuming slab thickness is 25, 27, and so on. Like that, we are increasing the slab thickness. Next, then another chart for finding the corner load stresses. So our slab thickness is 23 centimeter, whereas modulus of subgrade reaction K is 6 kg per centimeter square. So 23 centimeter and 6 kg. The corner load stresses is around 23 or 24. So corner load stresses is 22.6 kg per centimeter square from chart. So the flexure residual concrete strength is 22.7, which is less than 20, which is less. That's why design is okay. If it is greater, what we have to do? Then we have to repeat the procedure once again by assuming slab thickness as 25 or 27. This is the method for design of rigid pavement. Then, if this is the where we are designing the pavement by using chart, this is the method for design of pavement using the formula. So, what is the difference between using chart and formula? So, using chart, only the desired variable K is up. You can use this chart up to K is 6 kg per centimeter square. If in our design the K is less than 6 or greater than 30, we cannot use this chart. In that case, we can use the formula for design the rigid pavement. So this is the formula for finding a rigid pavement, that load stresses for edge region higher and load stresses for corner. This is the formula for load stresses for corner region. And another formula is also available for load stresses for interior region. Normally, in design of rigid pavement, we can consider only corner load stresses and edge load stresses. If corner load stresses and edge load stresses is okay, we may not consider load stresses in the interior stresses. Then adjustment for traffic intensity. So this is the formula for design traffic intensity in future. So if you now the traffic intensity is 500 commercial vehicle by the year of 2012. Then by the year of 2019, the number of commercial vehicle is 3994.03, where N is difference between last traffic count to 2019. Last traffic count is 2012. Then construction years by the year of 2019. The difference is 7 years. Then 20. Any idea about 20? 20 means if the design life of flexible pavement is 15, whereas this is rigid pavement. That's why we are assumed as a 20. Then R is growth rate. Normally in India, the growth rate is 7 to 9. We are assuming 8%. So which is fall on F class. So we can classify the class A to B, where A means where A means number of commercial vehicle per day is 0 to 15, whereas G means number of commercial vehicle above 4,500 and all expressway coming under the category of G. Our problem, number of commercial vehicle by the year of 2019 years around 4,000. That's why we are assume traffic classification is F. If the traffic classification F means with the adjustment factor is recommended by IRC code. Adjustment factor recommended by IRC code. Yes, this is the table which shows the adjustment factor. So traffic classification A to G, additional thickness as adjustment factor. If it is traffic is A years, the thickness should be reduced to 5 centimeter. Why we are reduced the thickness of the slab in 5 mm or 5 centimeter? So the if traffic classification A means number of commercial vehicle per day is only 0 to 15. That's why we are reducing the slab thickness 5 centimeter. Whereas the G is the expressway and number of commercial vehicle per day is greater than 4,500. That's why we are adding 2 centimeter. So yeah, this according to the design, that concrete slab thickness is 23 centimeter, whereas our G means the 23 should be added 2 centimeter. The total thickness of the cement concrete slab become 25 centimeter. But in our problem, the traffic classification F means no correction, no addition or deletion. That's why we are taking the design thickness of concrete slab is 23 centimeter. Then the 23 centimeter slab is divided in such a way. The thickness of the granular subbase 80 mm GSP grade 1. So we are already discussed our CBR of the subgrade soil is CBR of the subgrade soil is CBR of the subgrade soil is 8%. 8% is normal subgrade, whereas if the CBR of the subgrade soil is 8 or 2 to 15, 80 mm minimum thickness of subbase. That's why we are fixed 80 mm thickness of subbase. ATM TSP grade 1 having CBR value not less than 30%. The thickness over the subbase, there should be a base course. The thickness of base course may be WPM, waterborne macadam, or WMM, wet mix macadam, or we can go for dry lean concrete 148 10 centimeter thickness. Then cement concrete slab, cement concrete pavement, cement concrete slab, M30 grade concrete 23 centimeter thick. Then slab size 4.5 meter by 3.5 meter, that is joints. Joints may be expansion and contraction joints are to be provided on transverse direction, and longitudinal joints should be provided in the longitudinal directions. Then various layer thickness of rigid pavement. The subgrade CBR is 6%, so subbase is 80 mm or 8 centimeter granular subbase, and base course is 100 mm dry lean concrete 148, and cement concrete slab having 230 mm cement concrete slab in M30 grade. Then, if you are using reinforced cement concrete slab, 1 day out 10 M30 grade, 15 cubic meter is required. Whereas 15 cubic meter of reinforcement concrete M grade, we require cement is 6.1 ton metric cement required 6.1 metric ton, sand required 6.75 cubic meter, 20 mm aggregate required 8.1 cubic meter, 10 mm aggregate required 5.4 cubic meter. Like that, M20 grade, M20 grade, M25 grade. Then these are the methods available for design of rigid pavement and flexible pavement. Now we can close our construction, close our session. If it is any queries, we can discuss. Sir, வேற ஏதாவது கன்க்ளூஷன் பண்ணி ஒரு 2 minutes சொல்லவா சார்? ரைட் சார். Then conclusion. IRC method will be best suited for design of flexible and rigid pavement. Bituminous pavement are used as a surface course because of the reason that they are cheaper than cement concrete pavement. Further, the bituminous pavement shall be kept open to traffic immediately after completion of work. Then bituminous layers over existing pavement is possible. WMM or of CBR value greater than 30% is nowadays widely used as a base course in India and abroad. Necessity of sub-base course is based on the value of CBR of subgrade. Normally, GSP grade 1 as a sub-base course having CBR value greater than 30% is recommended. It is common to classify subgrade as weak, normal, and very stable based on CBR value of the subgrade. Yes, queries are invited. Thank you, sir.
Dear participants, if you have any queries, you can ask now. Post your questions in the comment box. We will convey them.
Sir. Sir, that is a dry process. That is a plastic tar road invented by Dr. Vasudevan, of Professor of Tyagaraja College of Engineering. In a dry process, we can go up to 20 to 30% plastics. There are the two process. One is wet process, another is dry process. In wet process, we are mixing polymer in bitumen. In this wet process, we can go up to 2 to 3%. So, in dry process, we are coating the plastics over aggregate. We can go up to 20 to 30%. Yes, sir. We can go for, there are the various methods available. One is we can improve the quality, we can improve the strength of subgrade soil. For example, if the existing ground is expensive clay or clay soil, we can add lime for increasing the strength of the subgrade clay soil. One of the method is adding clay, adding lime. Another is injecting cements and mortar in the subgrade. Like that, there are the various methods available to improve the strength of subgrade soil. That's why normally we are using 5% bitumen for bituminous road. So 5% bitumen, out of 5%, out of 5% bitumen, we can go for 20 to 30%. So normally, for example, for preparing bituminous mixer, we are taking 1200 grams aggregate. Out of the 1200 gram aggregate, 5% bitumen means 60 grams. Then 60 grams of bitumen and 1200 grams of aggregates are used for preparing bituminous mix. Out of the 60 gram bitumen, we can replace 20 to 30% plastic. So 20% means 12 grams replaced plastics. Instead of, for example, 60 gram bitumen, we are using for conventional method. In plastic tar road, 48 gram bitumen and 12 gram plastics can be replaced. Sir, for the maximum size of aggregate is depends upon the various layer. So the highway pavement having various layer. The bottommost layer is called subgrade. Over the subgrade subbase. For subbase, normally in India, granular subbase. For granular subbase, we can use up to 70 mm size of aggregate. Whereas base course, we can use up to 50 mm size of stone aggregate. For surface course, we can use up to 20. Yes. Yes, sir. Normally, there are the approach. There are the three approach. One is called empirical method, semi-empirical or semi-theoretical method, and theoretical method. So, this various approach. Like that, various types of design of flexible pavement is design formula recommended by US Corps of Engineers, group index method, and CBR method. In India, commonly used group index CBR method recommended by IRC. Okay, sir? Is it? So the best and most available method in India for design of flexible pavement is CBR method recommended by IRC. That is California Bearing Ratio method for any number of vehicles on road. So we can classify the traffic based on number of vehicles per day. If the number of vehicles per day is 0 to 15 is A classification. If it is A classification, we can reduce the thickness considerably. Whereas if the road having traffic volume more than 4,500 commercial vehicle or expressway, we can increase the thickness. And adjustment factor is also add 2 centimeter for thickness for pavement for slab thickness. Yes, sir.
Good afternoon, sir. So my question is, how the thickness of the pavement influences the thickness of the rigid pavement, sir, influences while aligning the hill road?
Pardon?
sir,
How?
how the thickness of the cement concrete pavement influences while aligning hill road.
Aligning hill road. Hill road only normally for the design of rigid pavement, temperature stresses are mainly considered. So the temperature stresses vary, the design is also vary. So we already discussed the temperature stresses. Based on the temperatures, they are divided the zone into four: zone 1, zone 2, zone 3, zone 4, isn't it? That temperature is one of the parameter in aligning hill roads. Mainly for aligning hill roads, temperature stresses only.
On the topic highway pavement design, hope the participants will get idea regarding this topic, and it will be useful for their further research works. And I thank all the participants who have joined this session. And you have a feedback link in the comment box. Please fill that as soon as possible. Then only you can get the certificates. Thank you, sir, for your wonderful speech once again.
Okay, thank you, sir. Thank you, one and all.
Thank you, sir.